Hello, welcome to this class on automation and the Internet of Things. Today we'll cut through the noise and see how devices actually talk in an IoT ecosystem and why your protocol choice truly changes your project's outcome. Picture thousands of sensors in a city, a greenhouse, or a production line, all producing data, all wanting to be heard. When you decide how they speak, you're deciding energy use, latency, security, cost, and scalability. There's no one perfect protocol. There's the right protocol for your context. Let's start with the application layer, where the well-known protocols live. We'll cover MQTT, then CoAP, and finally HTTPS. Keep this in mind. Each has a different communication model, which means different strengths and trade-offs. We choose based on the use case, the network conditions, and the device constraints. MQTT uses publish, subscribe. Someone publishes to a topic, and one or many subscribers receive it. It's lightweight, runs over TCP/IP, and relies on a broker to route messages. The magic is decoupling. Producers and consumers don't need to know each other, which makes MQTT very scalable. Quality of service comes in 3 levels. QoS 0 sends without confirmation, great when latency matters and the data isn't critical. QoS 1 guarantees at least once delivery, accepting duplicates. QoS 2 ensures exactly once delivery with extra handshakes and resource cost. Out of the box, MQTT isn't super secure on its own. In production, you should add TLS or MTLS, manage user/password properly, and enforce ACLs on the broker. This prevents unauthorized access and reduces dose risk. Best practices: least privilege, clear topic hierarchies, and broker monitoring. CoAP targets constrained devices and uses a REST-like style similar to HTTP, but travels over UDP to save energy. It has confirmable messages, wait for ACK and retransmit if needed, and non-confirmable ones when you can tolerate occasional loss. Because UDP doesn't encrypt, CoAP protects itself with DTLS for confidentiality and integrity. The trade-off is CPU/memory overhead, and since it's largely stateless, you must design carefully to avoid dose exposure. HTTPS is HTTP with TLS. It offers confidentiality, authenticity, and integrity, plus great web integration. The challenge in IT is weight. Maintaining TLS sessions, handling certificates, and doing OTA updates can be tough for small microcontrollers. If certificate rotation is neglected or older TLS versions are allowed, vulnerabilities appear. Still, HTTPS shines for APIs, device management, and updates as long as you run a disciplined security and maintenance process. In one line, MQTT excels at one-to-many distribution with QoS control and low friction. CoAP wins where energy efficiency rules and messages are small and sparse. HTTPS is your workhorse for management and web services, provided the device can handle it and operations are disciplined. Let's move to long-range, low-power connectivity, LPWAN. Lower AWAN uses a star of stars, devices gateway's network server. Long reach with ultra-low power. Device classes: A, max saving; B, scheduled receive windows; C, almost always listening, low downlink latency, higher energy. Security with AES. Prefer OTA for secure joins. Sigfox is operator managed, ultra narrowband, about 100 bps, daily message limits, extremely low power, wide coverage, but you depend on operator coverage. NB-OT is from 3GPP, licensed spectrum, deep indoor coverage, operator-grade QoS and reliability, more capacity than LoRaWAN/Sigfox, at the cost of relatively higher power and per-device subscription. In practice, IT architectures chain protocols. A sensor might speak LoRaWAN to a gateway. The gateway then publishes via MQTT to the cloud. With NB-IoT, it's common to see CoAP on the device and a bridge that converts to MQTT for cloud processing. These bridges are critical. They must ensure end-to-end security, provide buffering during link outages, and keep a consistent data model so nothing is lost or mixed. For prototyping, spin up Eclipse Mosquito on a Raspberry Pi, lightweight and easy. For scale, look at EMDUX or HiveMQ with clustering and high availability. Managed services like AWS IT Core simplify deployments, but may have MQTT feature gaps and the usual vendor lock-in risk. Quick checklist: TLS/MTLS and ACLs on the broker, clear topic hierarchies, plant/line/device/metric, retained messages for last value on join, lastful to detect drops. In CoAP, consider observe/blockwise and plan DTLS well. In HTTPS, target TLS 1.3, rotate certificates, and enforce reliable OTA. How to choose without getting lost. Continuous telemetry to many MQTT. Ultra-constrained link, tiny messages, battery first CoAP. Management, APIs, updates HTTPS. Massive coverage and years of autonomy lower AWAN/Sigfox. Operator-grade QoS and simplified admin and BIOT. 3 closing ideas. There's no perfect protocol. Design around energy, latency, security, scale, and remember interoperability and gateways are the glue of the system. Thanks for joining. In the lab, we'll deploy Mosquito on Raspberry Pi, publish from an ESP32, and verify with MQTT Explorer. See you there.